Okay, so these are just going to be the highlights of factoring patterns out there. So it's just good to recognize the different types. So the first one we're going to look at is GCF, or greatest common factor. So let me put up something that sort of resembles this pattern here. So 6x cubed minus 6x minus 6x. All right, I can take out a 6x. So if I do that, I'm left with x squared minus x minus 1. That is just one type of greatest common factor out there. And I think in this particular exercise, I'm not trying to factor all the way with this. Next up, factor by grouping. So something that we could apply this to x to the fourth minus x cubed plus x minus 1. If I look at the first two terms, I see that I can take out an x cubed, and that'll leave me with x minus 1. And then the second two terms, it doesn't look like I can take anything out, but I can actually factor out a 1 out. And the reason why I do that is it will fit this factor by grouping pattern. And so if I do this correctly when you factor by grouping, then these two binomials should match. In which case you can just group up the outer pieces, so x cubed plus 1 times x minus 1. And in a moment we'll review how to factor sum of two cubes, which is x plus 1. Matter of fact, let's just jump down there now. So x cubed plus 1. Anytime I have two things that are cubed, I can fit this pattern. This is commonly called the SOAP pattern. If you're not familiar with that, I'll kind of review why we call this the SOAP pattern. Anyway, so this factors into x plus 1, and that would be x squared minus x plus 1. And the reason why they call it SOAP is this first position is the same sign as the initial. The second position is opposite of that, and the third one is always positive. So same opposite, always positive. That's why they call that SOAP. Go back up to difference of two squares. So let's do x squared minus 25 which factors into x plus 5 and x minus 5. Little side note I've seen students get upset about. Whether you put the plus 5 or the minus 5 first doesn't matter. Whenever you're multiplying two things, order doesn't necessarily come into play. So x plus 5 or x minus 5 are both fine. Difference of two cubes. X cubed minus 1 would be an illustration of that. And again, this is another SOAP case, and I'll remind you of what that is in a moment. So that would factor into x minus 1, x squared plus x plus 1, and SOAP. So this x minus 1 has the same sign as the x cubed minus 1. The second sign is always opposite of the first, and the last one is always positive. Same opposite, always positive. All right, last two examples are just illustrations of perfect square trinomials. Back in Algebra 2 or in college algebra, you would have used some sort of variation of this for a process called completing the square. So I'll just kind of give us one to focus in on. So x squared plus 8x plus 16. And I'm looking where the last number is something squared, where I doubled the middle to get that 8. So if I square 4, I get 16. Double 4, I get 8. So that's why it factors into x plus 4 squared. And you can always just refoil that just to convince yourself that that's the right pattern. And then the last one, x squared minus 10x plus 25. So something squared in the last position, so 5 squared gives me 25, and if I double 5, I get 10, which is why it's x minus 5 squared. With factoring, it's just a lot of recognizing patterns and then just trying different things in the few cases where patterns actually are helpful. So, okay, so now we're going to look at sort of some general combinations of the various patterns and just seeing how to attack different factoring problems that are thrown at us. So in this first example, first thing I notice is that 2 goes into everything, 2, 18, 72. So smaller numbers are better when it comes to factoring. So I'm going to take out, do a factor out of 2. So that'll leave me with x squared minus 9x minus 36. And then my next temptation is, well, see, 36, that's a perfect square. So maybe that perfect square thing we looked at a second ago is useful. But in order for that to work, it'd have to be 6 times 2, or 12 in the middle. And since it's 9, then I can't use that. But I can use the old guess and check technique. So guess and check would be, think of factors of the last number, so this 36, that happen to add up to the 9, with pluses and minuses. So I know because it's negative 36, it's got to be 2 numbers that multiply to give me negative 36, and then those same 2 numbers would have to add up to 9. And the only thing that comes to mind would be 12 and 3. And if I make 12 negative and 3 positive, then that would, if I refoil that, I get a negative 12x and a positive 3x. That should give me a minus 9. Okay, so that's that. Number 2 here, the second one. I notice that I can take a GCF of 3 out, which is x to the 4th minus 25. And then this looks like a special case of our difference of 2 squares. So I can factor it into x squared plus 5 and x squared minus 5. And then part of me wants to think, well, I can just keep going with this, but we don't have that situation because we have 5 and negative 5, and those aren't perfect square numbers. So this is as far as we can go as far as factoring is concerned. Okay, x to the 8th minus x to the 4th, that's just telling me it's got to be a difference of 2 squares. So something, let's see, that would be x to the 4th and x to the 4th, and this would be y squared and y squared, with one being plus and one being minus. And let's see, the x to the 4th plus y squared, that's a plus, so I can't keep going on that, but I can apply difference of 2 squares to the x to the 4th minus y squared. So I'm going to bring down this, and so this would be x squared, and that would be y and y with 1 plus and 1 minus. And at that point, there's no more perfect squares, so I can't really do anything more with this. So I will stop here. And number 4, let's see, 3x to the 4th, x squared, y squared. So there's, first temptation is to do, or I guess not necessarily first, but one thing that popped into my head was to try difference of 2 squares. But there actually is an order of ops. If I can GCF it, if I can greatest common factor it and find anything to make it smaller, that'll save me some time. And hopefully you noticed that there's a GCF of x squared. And if I factor that out, I get slightly smaller numbers. And then 9x squared minus y squared, that is an example of difference of 2 squares. That'd be 3x minus y and 3x plus y. Okay, going on. Okay, oddly enough, number 5, we actually are looking at an illustration of a perfect square. If I look at 16x squared, I can square 4x, and if I double that, I get 8. So that would be positive 8, but with the minus sign, that just means there's a negative there. So this factors into 4x minus 1 squared. Number 6 is an example of a difference of two cubes. That's SOAP factoring formula. So I need, let's see, something that I cubed to get x cubed, which would be x, and something I cubed to get 8, which is 2. So it's x minus 2, and then it's x squared, opposite, so plus, then product 2 times x, so 2x, plus 2 squared, which is 4. And so that's that factoring pattern. Okay, this next one doesn't look like it has a GCF. It doesn't look like a perfect square. So our next, I guess our next bet is to try to guess and check it. I know it's got to be x squared and x squared. We'll multiply to give me x to the 4th. And then I need some factors of negative 80. They're going to add up to 11. And so that literally would be, you might want to make a little factor tree and go, well, I know what's 1 in 80 would multiply to 80, 2 and 40, 3 doesn't go in there, 4 does, 4 and 20, and then 5 and 16, 6 doesn't, 8 does, 8 and 10. Okay, so of this big list, one of these pairs are going to give me an 11. So the only way I can see an 11 is the 5 and 16. So if I go, let's say 16 and 5, and to get a plus 11, it's got to be a positive 16 and a negative 5. Now, quick point, had it been a negative 16, then we could have done difference of two squares and kept going, but it wasn't, so we stop here. All right, number 8 is definitely looking like a factor by grouping. So looking at the first two terms, I can take out an x squared. That'll leave me with an x minus 1. And the last two terms, I can take out a 3, which also leaves me with an x minus 1. And then grouping them up, I get x squared plus 3 and x minus 1. And then the last example we'll look at in this practice here, I got 4 terms, so again we're looking at factor by grouping. And the first two terms look like I can take out an x squared, so that'd be an x plus 5. The last two look like I can take out a minus 4, so that would also be an x plus 5 left behind when I factor that out. And then I can bring together the x squared and the minus 4. Okay. And before I circle it and say done, the x squared minus 4, it does fit our difference of two squares pattern. So that'd be x plus 2, x minus 2, and x plus 5. And there we go.